All right, hello there. Hello, guys, and welcome to this year's PSP Homebrew Developer Conference. We have plenty of talks lined up this year from developers both old and new. I'm your host, Iridescence, and together we're going to be celebrating the 20th PSP anniversary. Let's walk through the basic itinerary. First up, we have the Kurohyou Translation Project by Team K4L. This presentation will be about the fan translation of the Kurohyou and Yakuza games for the PSP. Next, we'll have Project Aether by myself, Iridescence. I'll be going over the history of my game engine design and a new game engine design project. After that will be the TOTP4PSP Authentication by arcyleung, which is a homebrew project to use the PSP hardware as an offline authentication token generator. He'll also be giving a brief overview of the development process. Next will be the ARC4 custom firmware by our returning developer, Acid Snake. He'll be covering the latest and most awesome features for the firmware. I did receive notice that he might come in later on the stream, so the following presentations may be a bit out of order. We'll have the SSL with curl presentation next by Bucanero, who will be explaining and overviewing the SSL support that he has added to curl for using the PSP with the modern web. Next, we'll be also having a great presentation by davidgf on the PSP Toolchain itself, which is the heart of the homebrew community. He'll be discussing what the team have done this year and their future plans. Finally, last but not least, we'll have a presentation from Wouter on porting games, both with SCL2 and the general process of porting a game to the PSP. And with one more final surprise, we'll be doing a short presentation video recapping all the greatest games lately made by you guys, the community. Wow, that was a great presentation of all the awesome community work that you guys have done as the PSP Homebrew community. Without further ado, let's go ahead and get on with the Kurohyou Translation Project by Team K4L.
Hello there, and welcome to our presentation on the translation of the Kurohyou games.
Sorry, small technical difficulty. Give me one moment.
Hello there, and welcome to our presentation on the translation of the Kurohyou games. I'm Augmented Smoke, team leader of Team K4L. So what are the Kurohyou games? They are titles developed by both Sin Sophia, known for the Def Jam series, and RGG Studios. They're actually spin-off titles in the Yakuza series of games, released for the PSP exclusively in Japan. So, about Team K4L. We are a 5-person team consisting of a translation and project lead, a technical lead, a design lead, and 2 playtesters. Geographically speaking, we are basically from all different corners of the world. What previous experience did we have before jumping into this project? Essentially, none. I spoke Japanese, but that was about the most I knew how to contribute. We basically had to pull our skills and try to learn as we went. So why translate a PSP game? Although by modern standards a PSP might seem somewhat obsolete, especially for the likes of a semi-open world action-adventure title, to me these games have always stood out for their vibe and their excellent gameplay, especially considering the technical limitations imposed by the hardware itself. These projects started after the release of an unfinished English patch of the first Kurohyou game. Some friends of mine were discussing how much they enjoyed the story and were very interested in playing the second game. I had already played the second game and it felt upsetting that I couldn't share my feelings about it, so I decided to translate the cutscenes and send them through to my friends. After completing a few of these cutscenes, I received a message from one of my friends saying he was interested in creating a full English patch for the second game. Of course I was as well, but had no idea where to start. This is essentially what began this entire project. With all that out of the way, how did we create a translation patch with essentially no experience? The first thing we did was to gather all the information we could. We consulted the PSP Homebrew community, sites like GBA Temp, and discussed with people who had experience. After we had enough information, it was essentially a matter of trial and error until we had a good understanding of how the game worked and its general file structure. We then determined our goals for the project. We wanted to make sure that the main story of both games as well as the side content were both fully playable in English. Next, it was very important to me that it worked on real hardware including a PSP and PS Vita. Ultimately, this ended up having a big influence on the way we went about certain implementations. And most of all, it was important to us to give these games a second chance as they did not sell particularly well in Japan on their original release. Next, I'm going to go over the basics on how the games work. I've split it into 3 main categories: text handling, textures, and UI/other. The majority of the game data is stored within a Crypack archive titled Kurohyou.cpk. Within this archive are other CPK archives which contain the relevant data. Luckily, they have been named in a way that makes it reasonably clear which files are where. However, this has proven deceiving in the past when trying to locate some specific files. Within these CPK archives, the most common format you'll find are pack files. These are a generic file type that can represent many different files found within the games. The most common of which, however, is as gzip archive, which contains yet another archive, usually of the ELPK variety. The way text is structured in Kurohyou 1 is as follows. All generic shop, NPC dialogue, and sub-story content is contained within a file labeled city sequence. This file is always loaded into memory so it can be accessed by the player. All text relating to menu, UI, and other system content is located within a file titled globals. It contains things such as item names and their descriptions. This is also always loaded into memory. Finally, there are the numbered sequence files. These contain story content and sometimes generic NPC dialogue that is affected by certain story chapters. As you can assume, these are loaded in depending on the story chapter that is currently active. For the most part, the text file structure in Kurohyou 2 is quite similar, however there are a few key differences due to the size of the second game. Similarly to the first game, all generic things that need to be accessed at all times by the player are located within a file titled sec_commons. This is essentially the same as the city sequence file. The other two files, sec_ka and sec_so, relate to the two cities you can visit in the second game. They contain all files related to that specific city, including sub-stories, generic dialogue, etc., and all of course loaded in whenever you visit that specific city. Because of this, sec_commons is also used if a specific sub-story goes across both cities. For cutscene text, the actual content itself is stored in plain text within a CSV file. Each cutscene is separated into its own folder which contains both the CSV file as well as the textures used. In order for the game to pass the non-Japanese characters, the font file needed to be edited by hand to include the missing characters. Certain characters such as quotation marks or commas have to use the Japanese versions of the characters as the normal versions are used as syntax that affect the text layout. To pass the text correctly, it needs to be packaged using a program that converts it into UTF-8 format, UTF-16 for globals, and adjusts the pointers. Due to PSP RAM limitations, we needed to change the encoding that the game would accept, as using English on the old encoding would use a significant amount more space. Originally, we had tried a few different methods to get around this, such as having different files for each chapter, but eventually we were able to get it working without any compromises. The texture files for the game are in GIMP format, which was commonly used for PlayStation titles at the time. These can be extracted and then edited depending on the need. However, it is important that the file size is kept the same, which can be difficult without sacrificing visual quality in some instances. The system UI was edited directly in the eBoot in order to get the save games to output in English. This was a delicate process, as having too much extra characters caused the game to crash. The texture was also replaced by an English variant. Here are some comparison shots of the game. We'd like to give a special thanks to the following people. Thank you so much for watching our presentation.
Wow, that was a really cool presentation. I really didn't know a lot of the stuff about the game packing and things like that. I thought it was really interesting. Thank you once again to Team K4L and for doing the Kurohyou Translation Project. Go ahead and check it out. All right, next up I have a presentation for Project Aether. All right, hello guys, and welcome to my TED Talk. I hope you guys are ready for a journey in engine evolution. So first off, this is going to be the overview of the entire presentation here. We have the table of contents. I am going to be giving a short introduction, getting into the lore behind my previous game engines, the problems that they had, and then Project Aether, which is solving those issues and making a better game engine, alongside of a status report of how far that's gone so far. So, quick introduction about myself. Hello, my name is Iridescent, and I've been a longtime PSP community member. I wear many hats, both as a developer, hacker, content creator, and homebrewer, and I work in a job in cybersecurity. I've worked on a long history of projects, some of which I'll be going over today, and how these eventually led to the formation of this project, Project Aether. I am the main developer on the Crosscraft project and the Zig PSP project as well. So let's get into step one, the lore. So here's the rough timeline that I have planned out here. The timeline are of major projects that led to the creation of Project Aether. I've omitted quite a lot of the other projects that I've been involved in just to simplify the timeline. So the start is MCPSP, which is kind of the first thing that I've done in the PSP community, which is a mod based on Woolio's Minecraft PSP, followed by the Shadow Engine, which is kind of spun off of that project, which is a heavily edited and refactored Aurora engine. I'll be covering what Aurora is. Stardust Engine is my first major cross-platform game engine, and Stardust Celeste is the revamp of Stardust Engine, which powered Crosscraft Classic and Survival Test. So, going ahead here, here's a rough overview. The first is Minecraft PSP, MCPSP, which inherits from Woolio's Minecraft PSP, inherited the base engine from Dracon's Lamecraft. The engine from Dracon's Lamecraft is called Aurora. It's the original game engine, which is significantly older, and it appears to power some of his older games like his Portal demo, the Multicraft project, and of course Lamecraft. I then moved on to Shadow Engine. Shadow Engine is not necessarily what I would qualify an engine, but it is more of a framework type of thing that you can use to make games. This was built by extracting some of the functionality from Aurora and the Minecraft PSP and extending and optimizing it. The Stardust Engine is the first engine that I actually created for the PSP, and the cross-platform aspect was new to me as well, and it came due to some of the increasing annoyances from Shadow Engine and the idea of starting from a fresh slate. Stardust Engine was the first attempt that I had made at doing a true cross-platform engine, and it was a major learning experience for me. Stardust Celeste learned a lot from the mistakes of Stardust Engine. I decided to do a major refactor, which broke a lot of compatibility, and because it was distinct, I decided to call it Stardust Celeste. Stardust Celeste in many ways is still, in my opinion, a good engine, but it still has growing pains that stem from some of the early design choices that I didn't really know, because I started this like 5 years ago, and I've definitely grown as a developer since then. So MCPSP was my fork of Minecraft PSP from Woolio. I say that like 3 times already. It was born from a lot of curiosity and wanting to add to the PSP community. Lamecraft was already an interest of mine, and I wanted to make my own. During the early development, I encountered many issues with the existing codebase and engine. Some of the following issues were the code organization. There is none. There's also issue with separation of concerns. You had some files that would do literally everything and had 30,000 plus lines of C++, which is disgusting. You also had issues with memory usage. So the memory usage layout of how Minecraft PSP actually worked, or basically Lamecraft, was that all resources were loaded at startup, and then past that they were never unloaded, which was actually really fine for when Lamecraft was just a game where you didn't have a menu, you didn't have like much going on, you literally just had the game. But when you have all these other assets that you're just keeping in memory, it does become an issue. And then there were some issues with modernization because it was using C++ 98. At the time it came out, C++ 11 was not even officially drafted as a standard, so it was still in the works. And so updating the code to use more modern semantics, a lot of modern C++ is just very vastly different than the original C++ 98. So from the learning experiences that I got from this was code reading and review. Obviously, you have to read the code to figure out what's going on. It also has a really unique feature, which is that it has a storied project. The entire depth of the tree of all the forks of Lamecraft would take me probably an hour to describe each one, and I don't even know necessarily the full history of that. There was a lot of refactoring involved, of course, because you're dealing with like variables that are used everywhere. So there's just a lot of compile and something else broke, and now I have to fix that too. So there's a lot of refactoring involved, and just really overviewing the architecture. Also, you'll notice I've been putting in QR codes. Those are links to the actual project if you want to go ahead and take a look at it. It's better than having to type in text. So the next thing was Shadow Engine. During my time working on Minecraft PSP or MCPSP, I began refactoring and rewriting a lot of the core functionality and packaging it into classes. This included for better resource management, which saw the project decrease memory usage by an extreme margin. I repackaged a lot of the code into a separate repo, and this was kind of the starting point of my getting into game design, or game engine design, rather. As is screenshotted here, this is actually a push that I made on July 2nd, 2019 for version 0.2.0a for my MCPSP. It's called Technically Updated, and one of the biggest things that you can see there is freed 16 plus megabytes of RAM. In fact, almost the entire thing fits into the RAM of a PSP Fat, whereas beforehand it was nearly hitting 48 or 49 megabytes of usage on the PSP Slim. So that tells you a lot. 16 megabytes of the PSP RAM, just as perspective, is 50% if you're using the PSP 1000 models, or if you have the higher end models, it's going to be 25%. But that's still a very significant amount of memory. So some of the things that I had issues with Shadow Engine were that it wasn't really a fully featured engine. It was kind of a framework that you just kind of built off of. So there wasn't really a separation between where the engine stops and the user game starts. So there's a little bit of that. One of the things that I noted that I did was I put Visual Studio project files into the repo, which isn't really a good thing to do because those things are massive and change a lot. There's also no dependency structure at all because it's just kind of yanked out of another game. So there's also minimal documentation to that. However, I did learn a lot, and I learned some lessons about how you should modularize different aspects of code rather than having them all be super integrated if you want to have an engine separated from the game, and also about resource management, as I covered, and some of the techniques around building a library, so separating your source and include files in C++, things like that, and how you could start to use that to integrate into other games. So then I went on and created Stardust Engine. I began developing my own vision for Minecraft PSP, divorcing it from the Lamecraft history and just really starting from scratch. I needed an engine to obviously do that, so I had some pretty ambitious ideas for what I would do with Stardust Engine, and probably made some promises I couldn't keep. I did take with me a lot of the lessons from the previous engines. I've worked on game engines external to the PSP outside of this, for years as well. So some of the ideas here are new to me for just the PSP, or just me becoming a better programmer in general. So basically, I started off Stardust Engine as it was just going to be a PSP engine, but very quickly I started porting it to PC and being like, why can't I just do this everywhere? So that was one idea. So Stardust Engine, I have a couple issues with that, which was the GitHub organization was non-existent. There were a lot of make files, and frankly, I could have learned that CMake would have made my life a lot easier, especially when you have different platforms. And there was a lot of project coupling. So there are separate modules. You have a platform, you have utilities, and you have some core game engine functionality, but all of them kind of rely on each other, so you don't really have a separation there, which makes it difficult. And in a way, this was a little bit too high level, as in a lot of the abstractions that I was making were great abstractions for one very specific task, but the second you need to do something else, you have a problem. So that was one of the things that I had a problem with Stardust Engine. A lot of stuff, though, I did learn from Stardust Engine, which was things like networking, dependency separation, cross-platform building, modularity, and engine design. So I started learning a lot about different fields of the things that I wanted to do. Networking was quite large for me because I had never really touched network code, and I kind of just started putting it all together in the course of 1 or 2 months. So then started Stardust Celeste as the PSP project ended and it turned to making Crosscraft a reality. I realized soon that if I wanted to be as multi-platform and supportive as I could be, I really needed to tighten up the code base, tidy it up, start moving from the model where the client uses the engine to the engine uses the client approach. So when the client, which is the game, uses the engine, basically the game is always the source of truth as everything comes from it, whereas the reverse approach is saying that the engine is the source of truth. It runs your code for you, and basically this fundamental mix of design actually increases a lot of the capabilities and makes it a lot easier for the game developer than it does the game engine creator. So by incurring some complexity, basically you can have a much more consistent and easier experience for the game developers. And that's what you see in Unity and Unreal and stuff like that, is that they call into the user code, whereas the user isn't the one writing the majority of the code. Some of the things I learned from this was I made some documentation, which is pretty good when considering nothing else was documented beforehand. I did a lot of client engine integration work. Project files and building got significantly easier. Stardust, if you wanted to use the Stardust beforehand, you had to do a bunch of makefile hackery. In the Stardust Celeste project, you literally just import it as a CMake module and do some defines. It was that simple. So it also was a multi-graphics library engine, so you could use OpenGL, you could use Vulkan, you could use whatever native graphics API was available to you. And this also reduced a lot of the platform leakage. It still exists, but the end user application doesn't actually have to care about what platform it's on. Some of the issues was that there were some degrees of insufficient internal abstractions. And what I mean by that is that if you're the one inside of the engine, you have to do a lot of checks and assumptions that you probably shouldn't have to do. There were some issues with profiling and debugging because there was no real profiling or debugging system, which means that performance metrics are very hard to optimize when you do that. There was this concept of duct tape platform support, where you would just have a bunch of if checks is just to define what platform you're on. If you're on the 3DS, you have to make sure that your code is only active in the 3DS branch, for example. And that results in a lot of issues, especially when you have a CI or something, where you just oh, I forgot to do an if check and it doesn't work on this platform. So there were also issues with undefined behavior and crashing. Those were kind of more limited, but it is an issue in itself. And the code size kind of exploded. There's a lot more code that had to be written in Stardust Celeste, just from some of the issues beforehand, which is the platform abstraction stuff. So some of the key takeaways was the platform abstraction. Stardust Engine has little to no concept of a platform, which bubbles into the user code. Stardust Celeste is very aware, but that plagues the entirety of the engine code. What I want to do is that I don't want to have to deal with a platform at all. And you'll see that in the coming slides. The project structure, Stardust Engine had a structure, but it wasn't particularly great. Stardust Celeste minimized dependencies to be their own separate modules and just imports the modules. The CMake integration has a little bit of issues where it's you need to set up and define variables, otherwise it won't understand what you're trying to do. But it was much better than Stardust Engine. Some of the performance and profiling issues was that Stardust Engine wasn't really optimized, but it was passable and had decent resource management. Stardust Celeste was a lot more aggressively optimized, but a lot of the lack of profiling hurts some of the potential of how fast it could be. So let's finally get into Project Aether. Project Aether, the mission of Project Aether is to make a platform-agnostic game engine. The game itself is actually a library, and the engine is the application. It's a complete inversion of what you would kind of think of. So the game, it gets loaded into the code, and basically the engine just calls into the user code and is just okay, here's exactly everything that you want, and if you want something, ask me. So you're talking only to the engine. The game itself basically only has to care about entity management, events, manipulation of state and resources. So the core fundamentals of the game rules itself have to be within inside of the game. Everything else is handled by the game engine without much intervention from the game itself. The engine handles the event loop, graphics, audio, input, and networking, stuff like that. So the vision is that Project Aether is my final game engine for the Crosscraft project. The engine would be able to run across as many platforms as possible and run well, and the game developer will not have to worry about what platform or differences in minutia there is between platforms. Everything is declarative, request-based, stuff like that. So in the design chart, this is a crazy design chart, here's basically the overview of the engine. Project Aether is written in Zig and uses the design chart as seen. The game library and the core library interact with one another through an interface. Right now I haven't decided, but that's probably going to be the C ABI, which allows you to actually use any language that you want as the game library to integrate into the engine. The core itself has the abstracted logic, including stuff like rendering, ECS, application state, events, and audio. So basically, the core doesn't actually really know much about the platform, but it has a set of interfaces which it can use to talk to the platform and request very specific things. So there is a layer of abstraction there. The platform itself, however, is very aware of what it's on. The platform interacts with the core for audio APIs, debugging, tracing, file, memory allocation, networking, and graphics. So all of these things are abstracted into interfaces. The core calls into these interfaces, and pretty much the platform deals with the discrepancies between different versions of software. From the state transition diagram, this is actually more towards the game application state. Application state diagram to the left indicates the use of control flow, and there are a defined number of states. So when the engine initializes with its own initial state, and it calls into a user function that gives back a valid state object. This then causes the first transition, which is implicit, to happen, which starts you into the actual state flow graph. So you start in the onStart. So when the state is activated, the onStart event handler will be called, and this is what you do to set up, oh, I want to have an image, I want to have a sprite at this location. The subsequent things then happen, which is onUpdate and onRender, which will be called by the engine ad infinitum. You have no need to actually interact with this. It just gets called automatically. This does have the implication, though, that your code needs to be able to not have any sort of coupling where in your rendering process, you're changing stuff that should be updated and vice versa. But yeah, unless any state transition occurs, these two are called infinitely. When a state transition does occur, the onStop event handler is called for the current state. The state is then dropped and the new state is used, which transitions to the onStart state and so on and so forth. So you have a defined state transition diagram. Another pattern that I'm going to be using, this is a little bit more technical, is vtables and composition. A virtual function table is called a vtable, and it's used for interfaces. It's actually what backs C++ classes and stuff like that. Any platform or specific implementation of a feature will have to emit one of these tables, and they usually consist of the data of the underlying type and the table of functions that are callable for that type. The functions that are defined for the specific implementation then make sure that it is the right type, and then that it goes ahead and does the actual platform-specific or implementation-specific method. These usually consist of the data. As you can see on the left, you have a pointer, which is just to the data and the table. And this is the graphics vtable, which has a list of all the functions that are callable on the graphics table. So on the left, these functions are guaranteed to be defined for all valid subsets, such as OpenGL, GLES, Vulkan Render Pipeline, also for PSP, 3DS, etc. These tables can be composed together from a single object to implement components and other useful abstractions. So you can have an object that implements multiple tables and then exports all those individual tables if you want to use them for something like a multiple inheritance or a trait type system. So finally, I'm just going to cover the current project status. So the status, currently I'm working on the platform module, and what's going on there is that I have the graphics pipelines for GLES, OpenGL, and Vulkan are supported. The performance baseline versus Stardust Celeste is about 2.5 times faster, so the latency between each frame is significantly decreased. So you have around 30,000 FPS idle, which, I mean, you've gotten to a certain point, but that's a proof of the latency situation versus around 12,000 FPS was what you could get on Stardust Celeste. The input system is in design, which is going to be tying into the core, and I'm also working on getting tracing support so you can have some nanosecond level like debugging information of like, okay, this method took this long and it called all of these methods, stuff like that. The second part is the core module, which is the application state. The application state transition actually fully works. The event system is done and integrated into the state transition system, and there is asynchronous update and render thread. I'm continuing to do efforts to reduce and contain platform abstractions, and also for the platform support. PSP support is work in progress with a lot of Zig PSP updates in the works. It's currently working on Windows and Linux, and macOS is unsupported forever. So I'm just going to finish the thing with one quote: "Live as if you were to die tomorrow and learn as if you were to live forever," which is a quote from Mahatma Gandhi, and it kind of summarizes my experience. So now I'm going to go to the live Q&A segment. So I will be taking questions from the chat. Let's see. Can you make Snake? Yes, yeah. At some point, you will be able to make Snake. Yes, yes. All right, we want an editor like Unity. I mean, that is obviously an eventual goal. I would like to do that at some point because it feels like there's a lot of things that you could do. What drew me to Zig? Particularly, the things that I liked is a lot of the simplicity. There's no, like, in C++, you have the issue where, like, okay, I declared a thing to exist. Now that thing actually runs the constructor function, and the constructor function does a whole bunch of other things behind the scene that mutate the state. I don't really want to do that. I want to be able to know that there's one thing and this thing did another thing. And in a lot of ways that's C-like, but some of the problems of C you can get away from, like unbounded arrays, and a lot of issues that result in undefined behavior are defined or cause like explicit errors. Also, a lot of error handling is very transparent to the user, which is some of the reason I prefer it. What has been the biggest stumbling block that I've had to overcome? A lot of it is motivation because when you're just building stuff for the PSP community, there's like, it is very niche, so you're not going to be able to reach out to as many people. And sometimes the like problems that you encounter are just really weird. Sometimes you'll just have, oh, my graphics are glitching, and I just have to know that that's because of some like random thing with the cache. There's a lot of issues that you have that are just like, this happened because of the very specific system I'm on, and it can't be replicated by literally anything else. So there's a lot of like problem solving that you got to do. Yeah, saying, would this work with other consoles? Yes, it should. The first one I'm thinking of targeting is the 3DS, because that one should be relatively relatively simple to target. I was also thinking about the Nintendo Switch as well, because I do have a Switch that I now have, and I want to actually try and do some homebrewing on it, and that sounds like a really fun project. All right, I'll be answering any other questions in the chat, but it's probably time for me to go on to the next presentation. So the next presentation will be the TOTP4PSP Authentication by arcyleung, which is a homebrew project to use the PSP hardware as an offline authentication token generator. Without further ado, let's get started.
Hello everyone, my name is Arthur. Today I'd like to share with you my project, TOTP4PSP. So this is my first time doing PSP Homebrew, and I'd like to thank the organizers of this conference for inviting me to showcase my project. So let's begin. TOTP, short for time-based one-time password. Nowadays, basically any online platform has this as a security measure. Having to enter a 6 digits code to log into your bank, social media, etc. What does the PSP have to do with it? Well, first let's look at the options and weigh the pros and the cons first. Most popular option is getting this code via SMS or phone call. It's the most convenient, but it's shown to be vulnerable to things like SIM swapping attacks, where essentially the bad guys can contact your telecom provider and pretend that you changed your phone number. And using that new phone number, they will intercept your OTP code. The second option here is using a dedicated app like Google Authenticator, where you can simply copy and paste this code to log into your website. The problem with this is there are known cases with clipboard hijackers that steal your clipboard contents, but same goes for your OTP code. And when these apps back up to the cloud, like Google Authenticator does, you should be even more skeptical. So some researchers did a write-up and found Google Authenticator to send the user's keys in plain text, which is a huge fail. So up until now, you see the theme where security is traded off for convenience, which is ironic because these OTP devices are supposed to add a layer of security. For a third option, we have offline dedicated hardware. You don't trust any online platform to store your keys. Originally, there were these coined battery fobs that displayed a code each time you pressed a button, and it would show you one code at a time. These existed in a time before smartphones. Devices were not always online and connected. You had iPods for music, PSPs for gaming, and your phone for texting. So fast forward today, I decided to repurpose the PSP's hardware to generate these codes offline as a backup method in case you lose your phone and if you don't want to use any online platforms. Well, how do you go about generating a TOTP code? According to RFC 6238, this is a document that serves as a guideline for implementing the algorithm. It's essentially a function that takes in two things. So first we have a secret key string and an integer timestamp, that is the current time in seconds divided by 30. I won't go into the details how this hash function works since I wanted to showcase more about the PSP's hardware, but I'll try to explain at a high level how these two things are used. So initially at time 0, let's say we have a user Alice. She wants to set up an account to log in at a bank. Both Alice and the bank server agree on this secret key, which is a string of characters. Let's just assume only Alice and the bank knows the secret key initially. They might use RSA or another key exchange method, but that's not important for now. Then at time t1, Alice wants to withdraw from the bank. She first takes the secret key, k, and the current timestamp t1, then computes this function to get the 6-digit code, 123456. She sends this TOTP code along with the request to the bank, and the bank performs the same calculation. Usually T1 is a window like 30 seconds. When the bank verifies that Alice's code matches its own computation, using the same key that was set up initially, then the request is granted. Alice gets her money in this case. But let's say in step 2 here, someone called Eve was eavesdropping and managed to get a hold of this code 123456. Now at time t2, Eve tries to impersonate Alice using the code 123456, which she stole from time t1. The bank will compute with Alice's key and the present timestamp t2, and it finds that it does not match the request. So it rejects the request. The smaller this time window is, the less likely attackers can successfully get access by guessing or replaying these codes. You need an accurate clock to perform this calculation. Okay, so now we need a couple things to get this working on the PSP. First, we obviously need to store the secret keys someplace. You can export these keys from Google Authenticator via a QR code, and it will give you one Authenticator entry per line. I chose to store them in a file on the memory stick, MS0, under this path. Then you can read this file line by line using fgets, which is a pretty standard way in C. Now, a more secure way is probably writing this file to the PSP's internal flash memory, which has a few unused partitions. I didn't know these partitions existed before, but I was too afraid to write to the flash in case I bricked my one and only PSP. Next, we need some buttons for navigation, things like scrolling a long list of OTP codes. This is straightforward with the PSP SDK. Reminds me a bit of Curse's programming, right? Except you don't have to memorize the ASCII codes to get a key press from the keyboard. It's all defined here. I haven't tried other UI libraries, so I went with the most straightforward way for now. So next, the OTP function itself, the hash function, which takes in the key and the current timestamp. I just found a C implementation off of GitHub. Again, not going to go into the details about how the hash works, but I recommend you read the RFC because it explains every step and it provides a list of test vectors, of which I found very useful to help me test and get my C implementation working. So far, we can read and store the keys, but what about the timestamp? How do we get that integer timestamp? So the PSP has an internal hardware clock, like most embedded devices, But here's where things started to get weird in relation to the hardware. Most C programmers probably are just going to use the time.h header and call time null to initialize it and get the epoch timestamp, the number of seconds since 1970, January 1st. On the PPSSPP emulator, which I use here at the top of the screenshot, it seems to work fine, but on the real hardware, I get a different value. You can see this value is much smaller in the first row. And flipping through the documentation, I found another function called sce kernel libc time. This time, it worked consistently on both emulator and the real hardware. So I ended up using this one. And as for the screen, to display things, we obviously need fonts. I used a pretty old library called Intrafont from 2009, someone by the name of Ben-Hur. What I didn't know was that the emulator actually ships with a different set of font files than what's on the PSP hardware. This is due to copyright reasons, since the font files are Sony's intellectual property. So as a result, I could only use certain fonts that were common between the emulator and the PSP. And to get the original fonts, you need to essentially dump them from the PSP's flash memory. Those flash partitions, which I mentioned previously. In the end, I ended up using the system fonts with this library. And although in the screenshot it shows this glitching, I'm not sure why it has this jumbled mess here. But as soon as I disabled the shadows of the fonts, it worked fine without a problem on both the emulator and the hardware itself. Okay, so a quick demo. I'm just going to use a website that has TOTP for login. So it asks me for the code now, and we can see here okay, so it worked as expected. Now, for future work, I posted this on Reddit, and there's a neat idea from someone which replied to me in the comments, that is importing the QR code directly using the PSP's camera, not having to go through to export the file, then save the file on the memory stick. Now, I don't have either of these cameras here, the two models, but I noticed they have two different resolutions. The old one has 1.3 megapixels, and the newer one actually has a lower resolution here at 0.3 megapixels. Now, this depends on two things, which the first being the resolution and also how well it captures still images, how blurry the result is. This is going to influence whether we need pre-processing and things like image correction, perspective correction, because the decoder algorithm depends on distinguishing the corners and the dots. As the image gets progressively blurrier, then the algorithm probably won't work as well. The second thing is finding a decoder library in C or C++ that can be compiled and lightweight enough to run on the PSP's hardware. This zebra crossing library that seems to work with the PSP SDK toolchain, but I haven't done extensive testing at this point. Okay, to wrap up, thank you again for listening to my talk. I've been Arthur. Hopefully this tool is of use to someone out there. Link to GitHub is right here, and there's instructions for you to try it on your own PSP. My email is here as well. I'm also on Twitter at arcyleung, and I'd love to hear your thoughts and feedback. Peace.
All right, that was really cool. Honestly, I didn't even know you could do that. It's such a cool idea to have and find a use for your PSP, even to these days. All right, next up we'll be doing the SSL with curl presentation by Bucanero, who will be explaining and overviewing the process of adding SSL support to curl for using the PSP with the modern web.
Hello, I'm Damian, and I will be presenting the new SSL support with CURL for the PSP. What it is, CURL, it's a library to transfer files across many protocols like HTTP, HTTPS, FTP, and many more. It's highly portable. It's built on C and supports many SSL libraries such as OpenSSL, mbedTLS, Polar SSL, Wolf, and many others. If you have used any operating system, you probably already have been using a CRL tool built for it. In this case, the implementation for the PSP, I used Polar SSL, now called mbedTLS. Again, Polar SSL offers a library, SSL library for embedded systems. It's built on C and it's highly portable. It's recommended for for any embedded system with limited memory or hardware resources. So yeah, that was my choice for this. One note is that the PSP already has internal libraries for HTTP and SSL, but those libraries are quite old as the system. Yeah, and again, they don't support the latest security protocols. So yeah, you cannot actually connect to TLS 1.2 servers. So why Polar SSL? I have been building homebrew apps on other Sony platforms like PlayStation 3, PlayStation 4, PlayStation Vita, and and in those other environments, I also have been using Polar SSL with CURL. In this case, the I started with the PS3 library that on the PS Lite SDK, they had an old CURL library plus Polar SSL implementation working when I was doing PlayStation 3 Homebrew. I decided to update that library to a more recent combination that had TLS 1.2 support. While keeping Polar SSL and CURL. That combination was working for the PlayStation 3, so I went ahead at that point and updated the build to CRL 7.64 and Polar SSL 1.3.9. And I got TLS 1.2 support on the PlayStation 3. Again, as that was working fine for the PlayStation 3, I also did the same library and SSL support for other platforms like the PlayStation 4 Open Orbis SDK. The PSP had had a SURL library, but didn't have SSL support. So when I was building my my first homebrew app on the PSP, I found out that the CURL library available was old and it didn't have any SSL support. So you could only use it for insecure traffic like HTTP or FTP connections. As I had this previous experience porting Polar SSL and libcurl to the PlayStation 3, the PlayStation 4, I decided to try and port the same combination of Polar SSL and CURL to the PSP to have a fully working TLS solution. So we could connect to secure HTTPS servers from within a homebrew app on the PSP. One note is that once I ported it from I started testing this Polar SSL and CURL combination on the PSP, and at some point I found out that in some cases some servers were not working, apparently depending on the supported SSL ciphers. So to address that issue, I decided to port mbedTLS. It's the same library again. It just they changed names from Polar SSL to mbedTLS when the project moved to a different owner. So to address this issue with certain ciphers, I mostly ported updated again mbedTLS to the PSP. And on the CURL side, it was quite easy because you just switch the SSL library from Polar to mbed, and that was all. One thing for mbedTLS, I had to remove the IPv6 support because that's not available on the PSP, and in this case, we don't need it. Now let's talk about homebrews and what we can do with these libraries. So for a demo, Origami K was another developer helping me with this presentation. He created a sample demo app called Joker. It's using C++, CMake, SDL. So those are cross-platform libraries available, plus libcurl and the SSL support. This demo app was built to showcase what you can do on the PSP using this new SSL support. The Joker app, again built by Kurigami, is a simple it's a demo app, of course, that just fetches a random joke from a HTTPS URL, and then it shows on the screen of your PSP. It uses SDL2, TrueType fonts, and again mbedTLS plus libcurl. Let's check it out. In this case, there's there's a small video. The app will boot up. You will have to, of course, select your access point. Remember that the PSP has some limitations regarding the Wi-Fi connection, you cannot use some security, so you will have to keep a proper router with a Wi-Fi, an open Wi-Fi router to connect. In this case, I suggest you to download the Joker app and run it on your own PSP. What else? In this case, I think that libcurl plus SSL support reopens the or PSP to to the internet. You know that most servers are now like don't allow unsecure traffic like on HTTP. Many servers will force secure sockets, and not just secure sockets, but they will also enforce like TLS 1.2. So if you want to if you want your Homebrew app to connect to a GitHub server or anything like that, like an API, request data from an API, RPC endpoints or something like that, you will be stuck without proper SSL support. So like I said, this will allow you to create Homebrew apps with TLS 1.2 networking support. You can download files, connect to APIs, even upload data. And again, since libcurl is cross-platform and it's supported in many different architectures and systems. Again, if you are just doing Homebrew, you also have this available on the PlayStation 3, PlayStation 4, PlayStation Vita. Now you have it on the PSP, and also actually you also have it, for example, on the PlayStation 2. They are building they built a port for the PlayStation 2. So it's very useful whenever you need to use the network to have these kind of cross-platform libraries. Here are some links. I will also share them on my GitHub repo, so you can download this presentation. You can also download the Joker app. It's available there, already built. You can also, if you want, you can check the source code. It's really simple. You can clone it, you can modify it, and hopefully you will be able to create some cool homebrews that get network support and connect back to the internet. Thanks, and see you soon.
All right, that was a really cool presentation. I honestly thought of a lot of ideas right there now that we have the ability to do this. I wonder if someone will make or port like an existing web browser, or maybe make some game launchers. That stuff would be really cool to do. The next presentation that we'll be doing will be a presentation by davidgf on the PSP Toolchain itself, which is the heart of our homebrew community. He'll be discussing what the team have done this year and their future plans.
Hello. Hello, I'm davidgf, and I'm going to talk about the PSP Dev Toolchain. I'm going to give you an update on it and what future plans we have for it. First, I'll walk you through the toolchain and what it does, how it works. Then we'll focus on binutils and GCC, which is the part that I mostly work on. We're going to talk about the upstreaming work that's been happening over the past year. And I'm going to be talking as well about documentation and testing efforts. Hopefully it will make sense in a minute why we're going to focus on that. And yeah, we can get started. So the goal of a toolchain, and in particular the PSP Toolchain, is to produce a bunch of software that can take your C code or C++ code and transform it into something that's like a binary, like an input BPV or a PRX module, so that you can run it on your PSP. It has a bunch of components. Some of them run on your computer, like the compiler, GCC, the assembler, the debugger, etc. Some other components run on the PSP, such as like newlib, libraries, all sorts of like ports from common libraries. When I talk about the toolchain, I usually refer to this first part, a part that mostly runs on your PC, as well as the C library and the PSP SDK, since these are the components that are really necessary to generate any binary for the PSP. All the other libraries are just like good, nice to have, and we have them in a separate repo in Pacman. So they are not, so to speak, essential for the toolchain. So I'm going to focus more on the first set of things. So for those who don't know, binutils and GCC are usually integral parts of any toolchain. Binutils is responsible for the assembly of assembled code. It usually takes a bunch of assembly code and generates object files. It can also do other things such as linking binaries. And it also has some nice utils such as like object copy, object dump. It can read ELF, inspect symbols, etc. This should support some of the Allegrex instructions, or the PSP CPU instruction set, so that it can produce good binaries for the PSP that the PSP can execute. And of course, GCC, which is one of the most well-known compilers. We of course use it because it's nice, and it also has support for MIPS CPU, which is pretty much what the PSP ships, with a few changes that we'll see in a minute. It does not support everything that the Allegrex CPU has, but we have some reasonable support for it. Some other things need to be done by hand. So for example, the BFPU, which we'll get into in a minute, is something that usually requires some assembly coding. So the Sony PSP CPU is called the MIPS Allegrex CPU. It is essentially a MIPS 2 CPU with a bunch of changes. Some of these changes involve some extra instructions that the MIPS CPU, the original MIPS 2 CPU, did not have, such as MIPS 32 instructions. Some others are PSP specific, that is, no other MIPS CPU ships them. And it also lacks, for some reason, some MIPS 2 instructions, not a lot of them and not important ones, but it's not a perfect superset of the MIPS 2. So it's a weird thing where it has some extra stuff, but it lacks some stuff. Obviously, it also has the coprocessor 2, which is called the VFPU, the Vector Floating Point Unit, which is very important in the PSP development scene, just because it supports high performance floating point operations that are very important for like 3D games. There's also some interesting stuff, such as some of these instructions that it ships have slightly different encodings. So they are the same instruction, but encoded slightly different from the MIPS 32 release. So that requires some extra work to accommodate them. Here's just a slide. If someone is curious of what differences exist between these two CPUs, I'm going to skip over it. But like if someone is interested, these are the instructions that we have or lack in both CPUs. So currently we have two forks, one for binutils and one for GCC, that ship our custom changes so that binutils and GCC can produce proper PSP binaries. The current version for binutils is 2.37. I believe the latest release is 2.42. So we are behind a few releases, but there should not be much more there. So it shouldn't be the end of the world. This fork has support for like these instructions that we just talked. And it also removes some of the MIPS 2 instructions that the PSP does not support. But most importantly, it has support for all the BFPU instruction set. which is pretty large, more than 200 instructions, as well as new registers, macros, and all sorts of small differences here and there. It also has some small changes for the linker, so that the linker can produce some interesting sections that we need to generate proper OS compatible PSP binaries. GCC is in version 13, which I believe is the latest one. It does have support to use some of these instructions that the PSP has. That's good for performance. It can use pretty much everything that's available in terms of MIPS to CPU. It also has some interesting patches to accommodate the floating point unit. Both the PSP and the PS2 are very unique in that they lack double precision support in hardware, so they only have support for single precision. That's pretty unique. Not many, I believe only one other MIPS CPU has this issue. MIPS CPUs usually have either full support or none, so we have a bunch of things to accommodate that. It also has some other small stuff that we customize there, but nothing too big. So in the past year or two, I've been working on upstreaming some of this work. That means integrating some of our changes into the upstream vanilla versions of binutils and GCC. That way we can enjoy from free maintenance, essentially. We can also preserve some part of history and make sure that we don't have to rebase our code base as much as we usually do to keep up with the new version. So far, we got so far as to add some basic allegoric support in binutils 2.41. It's pretty basic. It does not support any BFPU instructions. It's just the base CPU with all these small instructions that I've described that are different from both CPUs. Also, we didn't get any progress so far with the GCC support, but I am hopeful. The challenges ahead are essentially that MIPS is a pretty much dying CPU. Not a lot of devices use MIPS CPUs anymore. Only small routers or small devices, usually cheap Chinese devices use MIPS CPUs. And there's not a lot of interest. There's not a lot of people maintaining these code bases. So it's very hard to get some stuff there. Over the past week, I got some traction on this, so maybe it's not as bad as it seems. So I'm hopeful that in the next months we can get more support and maybe accelerate some of this support. So I'm hopeful. Another major challenge is the lack of proper public documentation, as opposed to the PS2 that had a bunch of documents that were open and public. The PSP has none of those. There's some documentation that developers back in the day got, but of course it's not public and it's not really usable for us. And ideally we would need some documentation such as the PS2 so that any upstream work can be warranted, so that maintainers can have some documentation to refer to whenever they do some of their work. That's a pretty important part. So since no documents exist, and all we have is a bunch of unreliable-ish sources, such as blog posts, a lot of forums, code bases like emulators or Homebrew that use some of this stuff. I set to create a new documentation that compiles all of these blog posts and forums to make sure that we have something that's reliable that we can all use and we can refer to, and it can help us with this upstream work. So one of the ideas that I had was if we collect this information, this documentation, and we publish it, it might be good, better than nothing. But of course, we might run into the same issue. We'll just have yet another source of information, another source of docs that we do not know for sure that they are accurate or correct. So we're just going to make the problem worse by not having a proper way to validate these docs. So I set my way to create a documentation that can be somehow validated so that we can know that the documentation is accurate and correct. And thus BFPU docs was born. You can check the online docs at this address. And there's a repo you can contribute. So what does it mean to have a documentation that can be validated? This we have implemented in a very interesting way. So we have described our instruction set in a YAML file, This is a big YAML file, around 2,000 lines of code, that contains all the instructions that the BFPU supports with names, syntax, encoding, and they also contain a C-like implementation, so like pseudocode, the kind of thing that you can read in an instruction set manual. This YAML file will then later be used by a bunch of Python scripts. Obviously, one of them will generate a documentation like in HTML or PDF format. This is the classical manual that you can read in other CPUs such as ARM or RISC-V. But we also have a script that will consume this file and produce a bunch of tests. These tests are completely auto-generated. They try to cover all the instructions, and they have a test for every single claim we do in the YAML file. So they will test things such as, is the pseudocode correct? Does it do what it says it does? For this kind of thing, it will run the instruction with a bunch of inputs and check that the output matches the output of the C implementation. It will also test some of the other claims that we do. For example, we have information about performance, accuracy of some instructions. So they will just run a bunch of instructions, measure performance, measure the accuracy of the output, etc. And output a report that will say, well, this instruction and this implementation actually makes sense, or there's a mismatch, and then requires us to amend or fix the documentation. We have tests that validate the C code. These tests, as I said, they use different inputs to validate that the implementation makes sense. We have tests that validate performance as well and accuracy, as I mentioned. We also have some interesting, very specific tests that validate some of the information about register conflicts and prefix compatibility. If you have some knowledge about the BFPU, it has some interesting restrictions where some instructions won't like if the input and the output register are the same or they overlap. And in those cases, you should generate an error. Otherwise, you will end up with a wrong output. So we put that information in the manual so that developers can avoid using those. And we have a bunch of automated tests that try to find all the incompatibilities by essentially brute forcing all the instructions and all the possible combinations. The same applies for prefixes. We try to use all the prefixes with all the instructions and see which instructions actually do not do what they are supposed to do. That way we can generate all this information automatically without having to write any manual tests, nor having to go into other sources of documentation to see whether something works or not. There's also a bunch of manual tests, not many of them, but some stuff is still done manually. For example, things such as exception handling, some of the claims that are very specific and very corner cases where you just need a test that tests that very specific thing. So how does this documentation look like? It looks like something like this. For each instruction, we have a page, and in each page, we have a bunch of information for the instruction, such as the name of the instruction, an English description of what the instruction does, the syntax, so that developers can know how to use it. It also has information about the performance, like throughput and latency. It contains information about register and prefix compatibility and how restrictions on those work. And obviously has the pseudocode so that the developers can know exactly how the instruction works and what it outputs, because sometimes the English description cannot be 100% accurate on what it does in a meaningful way. It also contains information about bugs or errata. So if the instruction has a well-known bug or issue or corner case, it will be there. So this kind of documentation has a lot of advantages. One of them is we don't have to write a lot of these things, the documentation is auto-generated. So by changing the Python scripts, we can add more information that we might have. We can represent, change the format, the style. We can cross-reference instructions and whatnot. It also allows for easy adding or editing or changing instructions, tests, etc. And it also allows us to generate some data for other purposes. And this is very convenient. For example, we could auto-generate all the possible instructions that the BFPU can execute. And that could be useful for test cases for bin utils, emulators, for instance. So we can do a lot of things in an automated way that can be useful to other projects, not just us. It's also true that we are using this already for other projects. As far as I know, the Rust PSP project has used some of this documentation to improve their BFPU support in their inline assembly. I think they added some instructions that they were missing, just because now we have an exhaustive list of instructions and how they work. So for them, it was easier to just use this instead of like manually adding some of this. PBSSPP does not use this at all yet, but it could be useful to them if they want to run some tests, or they want to have some regression testing, or all sorts of testing in a way that they can make sure that their emulator does not have a CPU emulation regression, for instance. So wrapping up, we can say now that we have better documentation for the PSP CPU, and it's like open documentation. It's testable, so people can know that it's more or less accurate. We also have some support upstream for being utils, which is amazing. And we also know that we need to do some more work to get BFPU support there, and that we still have not support in GCC for the MIPS Allegrex. But I'm hopeful that we're going to get there, and that we're going to convince some of the maintainers to give us a chance. I'm going to take this chance to call for help. If you have some contacts in the GCC community or the BinUtils or FSF community that might want to contribute or help us, please reach out. If you want to work on the docs as well, or contribute or file any bugs, I think at the time of writing this, there's at least a known bug in the repo. So yeah, please reach out. You can reach me out on GitHub or on Discord. And this is the end. Thank you for your interest. I want to thank some of the folks in the PSP dev community, as well as in the PPSSPP community, for helping us through this work. It's been great working with you guys. It's a pretty cool community. See ya.
Wow, that was really cool. I wish them the best of luck in getting that upstream to GCC. Our next presentation here will be from Wouter, and it will be on porting games, both using SDL2 and overall the general process of porting games to the PSP. And after this will be Acid Snake with Arc 4.
Hello, everyone. My name is Wouter, and I'll be talking about porting games to the PlayStation Portable. Originally, this was going to be very SDL and CMake specific, but this kind of applies to everything. So I just renamed it for now. So for this, I have a 7-step process, which I'll be going through. Step 1 is to find a game you want to port. So what's important when trying to find a game you want to port is that we have the source code available and it's in a language which the PSP supports. And we also want to consider that it should be a game that could be expected to work on the PSP. Like, we're not going to port Crysis 2, but like little game like this one, like small puzzle game, should work just fine. And so the best website to look for games, generally, I would say, is osgameclones.com. They have a list of, for each game you might remember from a long time ago, or maybe even games that are out today, where there are like clones or remakes or reverse engineered versions of the code, or maybe the code has been released. It will be listed there. Also, you can look at GitHub topics. There's like topics for like SDL, for like game, some other ones. They also lists online for open source video games. There's one on Wikipedia. You can find other ones. Just search online. So games that are easy to port are generally the ones which are made using C or C++, because those are the languages we have the best support for. We have some other languages too, but I won't be going over that right now. Games that use CMake to build are much more easy to build because they use just one build file for every platform. We don't have to make our own. And we really like SDL2 here because it abstracts all the platform specific things and we have good support for it. Also, games that are easier to port are like 2D games or games that use like OpenGL1. We have OpenGL1, and games that do not rely on high resolutions are also a must. So step 2 would be to figure out how to build the game you picked. This is about the original platform. Like we want to figure out, so how do we build it? And we want to play it a bit to make sure we like it and we know how it works, how to build it. It's all very important information. Like we can't make a good port if we don't know what the original is like. Step 3 then is going to be trying to build it for the PSP. It's mainly like CMake specific, this step. We're just gonna YOLO it. We're gonna replace CMake with PSP CMake and see if it works. If not, that's expected. If it does, that's kind of cool. That saves us a lot of work. So then, we're just going to assume that the previous step didn't quite work. It gives you some error message. It's a good starting point. So step 4 is trying to get it to actually build. If it's not CMake, then we might have to write a make file. Otherwise, we just keep at CMake. We fix some errors there. At this point, we don't care if we keep other platforms working or not. We comment out code that causes issues that is not easy to fix. And for now, we only make changes that help the actual compiling of the code. Make sure to check like compile options, because there might be like, for example, a lot of games have translation support. We don't have a library for that, but oftentimes you can just disable it. Then you don't have to deal with that. And make sure to track your changes in Git, because now we're just breaking things to get it to compile. We'll need to unbreak it later. So we want to be able to track like what did we break. So once it finally builds, it comes to linking, and you'll see the compiler telling you that it's linking and that it didn't find where a certain function is supposed to be. To fix this, we just need to use either in CMake the find package function, or we can also use package config, and in a make file we would also use the PSP package config. But this will only work if the library is already available in SDK. Otherwise, you might have to port a library, or even in some cases you will want to replace the library that's being used. For example, Vulkan or DirectX or Boost, it's not worth porting those. You can replace that code with something else. Well, step 5 would be getting it to actually run, because now we have code that builds, but it's going to crash. I can almost guarantee you. So first thing we need, and this is absolutely necessary, we need to have PSP Link and PSP GDB, and we need to know how to use them. If you go to pspdev.github.io/psplinkUSB, you can read about it. It doesn't take that long. It's the difference between the application crashes and I don't know anything and I'm stuck, or the application crashes and I can see exactly what happened and what code caused it to crash. Like, that is the difference between being stuck and being able to get the work done. So some common crashes. the PSP module info might not be in the code yet. This is required. That's what you see here on the right. If an application doesn't have this, it will not work on PSP. SDL has some ways to do this for you, but doesn't always work. Just try and add it. Assets might be in the wrong place. Like it tries to load an image and it isn't where it's expected to be, causes a crash. Images might also be too large, like 512 by 512 is the maximum size the PSP can load. Also, if it's not quite 512 by 512 but smaller, you don't have this crash, then you might still run out of memory because all the images are way too big. And the code might also just be broken because we've been messing with it. Yeah, remember the comment out code? Yeah, this is the time where we address that to some extent because, well, it might be required after all for it to run. So eventually you'll get maybe something like this. This is, I was trying to port OpenBlock, which is a Tetris clone, and it's not supposed to look like this, but this was the first time I managed to start it, and that is a huge milestone. But now for step 6 is getting it to run well, because we don't want this with no controls, and the image is not, like, it just doesn't look like it's supposed to. Like, look on the right, that is what it's supposed to look like. That's where we want to get. So one of the things we'll want to do is we want to downscale some of the images to fit the size of the PSP screen. We don't want the PSP to spend its resources trying to resize things. And like, for example, this Ocean Pop, here it's at 920 by 180. We need it to fit on the PSP screen, which is a lot smaller. Here's an even smaller example. And gamepad support. This is not a hard one, but an important one. SDL has so the SDL gamepad API is really good. It's easy to use. And if you're not using SDL, the PSP CTRL library in the PSP SDK works just fine. It's also not hard. Now music. I put here music hits hard because it costs so much performance. Like OGG is almost unusable. It will eat away at your CPU. Try and avoid it. Change it to something else. Like MP3 is okay-ish. Wave is even faster. In some cases, music is kind of optional, and you need the performance. You could just disable music. And also we need the music to be in the right format. So one wave is not the other wave file. We might need to resample so the PSP doesn't have to convert it to something it can work with. So to get back on the maybe you don't need music, there's maybe also other things you don't need. Like, are people gonna play online multiplayer on the PSP, or maybe not? Like level editor, certain modes. Maybe the main mode is good enough for your port. You don't need the other things. That's fine. Also, 60 FPS, fancy animation. Sometimes it can be a bit more stuttery, 30 FPS. Like, it's fine. So high-res stuff we don't need. We have a small screen. Well, step 7 is, of course, you have your game working now and you share your creation. Because that's what we're working for, right? You want to play the game, but we do too. Like, we love getting new ports in our community and seeing people's work. Please share it with us. You might also want to share it with the original creator, but that comes with some caveats. Like, the original creator will not appreciate code that breaks everything except for PSP support. So you will have to unbreak the code. This might take some time, and I would advise you to talk to them before doing it, because it could be a significant investment. One advantage though, if a new version comes out, maybe PSP support already works after you've done this, which is great. So, some tips and tricks. This one is very useful if you want to contribute your code back. This is in C and C++. You can just be like, we have some PSP specific code and we have some code for other platforms. The compiler will figure this out for you then. Also, ImageMagick is a great tool for converting and resizing images. Like, it can convert images from JPEG to PNG. It can also resize them to any size you want. And it can even bulk resize things, which is sometimes very useful when trying to get the game to run. Also, if you need to resample or convert some audio or video files, VLC and FFmpeg are amazing. FFmpeg is a command line tool. VLC is it's your regular GUI. They're great. Then, I wish you all good luck with trying to port games. Here's my game working on the PSP. For you, it will probably not be as much work as it was for me, because I made the SDL port for PSP work, because we didn't have it working that well back then. But today it's great and you can use it. Good luck.
That was a really cool presentation, actually. I hope to see at least 20 more ports by tomorrow for the PSP. All right, up next we're going to be, last but not least, Arc 4 custom firmware by our returning developer, Acid Snake. He'll be covering the latest and most awesome features of the firmware in a live demo. Just give us like 1 moment here to get it set up on the Discord call.
Hello?
Yes, I believe they can hear you.
Well, no, but I'm having. Hold on. I'm supposed to be able to hear from the headphones. But. Hello?
Hello.
No. Hold on.
Yep, it will just be 1 minute here. Hello. Okay.
All right, so turn on the camera. Get a decent. Hold on, let me get a decent angle. Why is it opening? Come on. Like everything works at first when you're doing the all the testing, but then when you gotta do the live demo, everything breaks. I hope this time it doesn't.
Yep.
So first of all, the first thing I'm gonna do, actually, I'm not gonna boot up the PSP Go because, well, it's already booted up. I can show you a few features here and there, but I only really brought it here to show you that Arc works here. So it's like basically proof that it works basically in every PSP model you can find, even some of the more rare models that includes test kits and dev kits. And to demonstrate that, I don't have a test kit myself, but very recently it was discovered that you could grab a PSP 1K, which is what I have right here. As you can see, it's 1K. Gonna boot it up in official firmware mode. So I'm gonna shut it down. I'm gonna boot it up in official firmware mode. And very recently, like a few years ago, it was discovered that you could modify and install the testing tool firmware on these models. So essentially, you're turning your PSP 1K, your retail unit, into a test kit. And as you can see here, one thing that you'll notice is that the music and video options are missing because test kits and dev kits have no audio or video stuff. They're basically only meant to be able to play games for testing. If I go down here, you'll see that I have the debug settings, a bunch of different things, and the install package, which doesn't really work, doesn't do anything. We haven't even bothered to check if we can make it work because, I mean, installing Homebrew on the PSP is easy. It's much easier than using a package manager. Debug settings is something that is actually available to every PSP model, but it's hidden behind some QA flags that Arc can allow you to enable. I'll show that later. But basically, what I wanted to show is that this is not your typical 6.60 firmware. This is 6.60 testing tool revision A. Basically, it's a completely different firmware, though it's still 6.60. And well, as I explained in before, when I do these presentations, I try to make them so that I'm basically picking up where I left off the previous year. So basically, the previous year I was trying to do a live demo, but most of my consoles didn't have any battery. I didn't have some things installed that I wanted to show. So basically, the previous presentation was mostly a PowerPoint presentation and very little live demo. So now we're gonna do that live demo and we're gonna dig a little bit deeper into the custom firmware. So basically, I'm not gonna be repeating myself, but I am going to be remembering some stuff that I said in previous years. And one of the stuff that I said is that Arc has in its core custom firmware, it was designed to be compatible with future ePSP, in other words, Vita PSP firmware updates. So basically, what we noticed during the ePSP scene, the early PS Vita ePSP scene, we noticed that Sony kept updating the firmware, but they never really changed the NIDs, the function identifiers. They only really changed code around, and basically the custom firmware had to be updated to accommodate for the new offsets. And that was also troublesome because if you have users on one firmware and users on another firmware, you're going to have to create different builds. So what we did was we created a system of dynamic patching. Basically, it's instead of having code that says, inject this patch here, what you do is you have an algorithm that tries to identify where to patch, so that it doesn't matter if the code is moved a little bit, because the functionality is always going to be more or less the same. You're going to be finding that the code you want to patch is almost always going to have some identical instruction, some unique instruction that you can scan. Again, I'm not going to go into much detail, but the end result is that not only you can run Arc on pretty much any ePSP Vita firmware. So Arc runs on the latest Vita firmware 3.74, but it can also work on as early as 2.10. That's like when Arc2 was created, and Arc2 was the first iteration of Arc that incorporated dynamic patching. So So when I ported Arc back into the PSP, having dynamic patches helped. Finishing whatever static patches was left and rewriting them to dynamic patches was basically what needed to be done to get it fully working on PSP, but also working on something as weird and as rare as your testing tool firmware or the development tool firmware. I don't have a dev kit, a development tool firmware, but there are users who do have it, and Arc works perfectly on them. So I'm gonna show you. I'm not even gonna show you Arc booting up using the Arc loader because the Arc loader is basically a live custom firmware. It's not temporary, and I want to show you the power of Arc by showing you that not only you can run Arc on testing tool firmware, you can run Arc with CIPL, so you can run permanent custom firmware on your test kits and also on your dev kits. So now I'm going to turn it off, fully turn it off, and I'm going to turn it back on. I'm not going to press anything so that Arc loads. And as you can see, it loads pretty damn fast because it's CIPL. And as you can see, we're booting up Arc 4.20.68, revision 12. The latest one is revision 13 that was released like a few days ago, but it doesn't really change anything in the custom firmware. It was only a release for the PC utility to create DC Arc installations. I'll get to that later on. So as you can see, I still have my installed package debug stuff from testing tool firmware. If I go to system settings, you're gonna see that it's R4 CIPL. Okay, more things that all right, so there's a few limitations when you use the testing tool firmware. One of them is that originally you cannot play PS1 games because the testing tool firmware doesn't have the PS1 emulator built in. It makes sense if you think about it. Test kits and dev kits were created for testing PSP games, not PS1 games. So they don't come with PS1 support. But I did add some patches into it that does allow some degree of compatibility with PS1 games, though it requires using Pops Loader. This was added very, very recently, and so far we've only been able to get it working on testing tool firmware using Pops Loader. For me, I can only get Pops 6.00 up to 6.39. 6.60 doesn't work, and anything below 6.00 doesn't work. But I have other users with real test kits, not this retail converted unit, but a real test kit, and they say that they have better luck with stuff that's like 4.01 and below. So it's really a hit and miss. But anyways, I'm gonna just load any one of these, so I'll show you that I was able to get PS1 games working on this firmware that's not supposed to be able to boot these games. But if you really want to have full, like let's say you have one of these 1K PSP with testing tool firmware, and you're really missing out on a lot of stuff. For example, you no longer can play UMD videos because, like I said, test kits and dev kits are for PSP stuff. They're not for audio or video. So if you put a UMD video here, or if I try to mount, I don't have any ISO video here, but if you try to mount them and try to access them, they won't work. So let's say you have one of these retail 1K that you converted to a test kit, and you're missing some of the features that you want to have from a retail 6.60 firmware. Well, don't worry about it. We have this magical thing called Time Machine. Now, Time Machine was created like a long time ago. It's one of the earliest and one of the most important pieces of software for the PSP. And what Time Machine does is that it allows you to boot any firmware, any PSP firmware, including custom firmware, from the memory stick, entirely from the memory stick. So like the entire firmware is installed on the memory stick. So with models like the PSP FAT that are compatible with basically every firmware ever, 1.00, 1.50 upwards, you can use Time Machine to have like multiple different firmware installations, so you can dual boot, triple boot, quadruple boot, do whatever, how many boots you want to do. In this case, I only have one installation of Time Machine, and that installation of Time Machine is installed within DC-ARC. Now, DC-ARC, DC stands for Despertar del Cementerio, which translates to Awakening from the Cemetery. It was created by a Spanish hacker named Dark Alex. You might remember him from stuff like the M33 custom firmware, which is basically the granddaddy of ARC, so to speak. So like Pro and ME are the parents of ARC. ARC was basically created originally by the same people that created Pro and ME, though they left a long time ago. But Pro and ME are based on M33, so we can say that M33 is like ARC's granddaddy. And we have Despertar del Cementerio, DC for short, in like built into ARC, so you can create magic memory sticks, and you can create your Pandora batteries, and you can boot up ARC DC or DC ARC, and you can boot up ARC from the memory stick. And I'm gonna show you how to do that right now. So I'm not gonna show you the process of creating a magic memory stick because I already have one created, but it's basically you run this app called ARC DC Installer, you follow the instructions, and it'll generate a magic memory stick. If you get an error because the stick is not formatted correctly, there's this other app, I don't know if I have it here. It's called PSP Tool. Yeah, I have it. PSP Tool, you can format your memory stick to the proper formatting that you need for ARC DC. And yeah, once you have a magic memory stick, which I already have, so I'm not going to run the program, you need a Pandora battery. I am very lucky to own an official battery, OEM Sony battery on this 1K, so I can Pandorize it. And how do I create a Pandora battery using the PSP itself? It's simple. You have ARC. With ARC, you have a lot of tools, a lot of features that make your life very easy. So I'm going to go to Advanced VSH menu, and I'm going to go right here to Convert Battery. And right now it's in normal, and it's going to convert it to Pandora. So I'm going to click on it, and that's it. And I go back, and now you can see that it's in Pandora mode, and I can convert it back to normal, but I'm not going to do that. I'm going to shut down the device, and I'm going to remove the battery. You can tell it's an OEM battery. I don't know if you can tell. Sony OEM. So I'm going to put it back in, and as you can see, it lights up automatically. I'm going to hold the L button because it's configured to boot up with the L button. And there you go. This is basically Despertar del Cementerio. And why is it called Despertar del Cementerio? Because you can awake your PSP from the cemetery. If your PSP is bricked, you can unbrick it using a combination of a Pandora battery or a magic memory stick. So here I have multiple options. The first one is to install 6.61 ARC from scratch. This will format my flash 0. I don't want to do this. This one will install 6.61 official firmware. I have some NAND operations here, like dump NAND, restore, format flash, ID storage stuff. Like for example, oh wait, dumping NAND. They done. I didn't want to do that, but whatever. Just wait for it to finish. It doesn't hurt to have a NAND dump. It never hurts. Anyways, so ID storage tools. We have stuff like create new ID storage, change region. I'm never gonna tell people to use this feature because this feature flashes the new region into the ID storage, so it's a bit nastier. ARC already has another feature change the UMD region without having to flash anything, and it works on the fly. You can change the UMD region on the XMB using the VSH menu, and it's much better than using this version. So what I'm gonna do is, there's hardware info, stuff about my PSP. So I'm gonna boot 6.61 ARC from memory stick. And what you're gonna see now is that it's booting up the retail PSP 6.61 firmware. It's no longer gonna be testing tool, whatever. All right, so. Oh. Okay, I have the debug settings, but this is because I'll show it here. If I go to custom firmware settings, well, in the extra sections, the first thing you're gonna notice is these 3 new entries. I'm gonna explain them. Custom firmware settings, basically, the name implies you can enable different functionality built into Arc. If you think about it, the way that I created the settings in Arc is very similar to how plugins work. So you can think of custom firmware settings as sort of like built-in plugins, sort of, you know. So here I have the QA flags enabled, and this is what allows me to have the debug settings on a system that's not really a debug system. This is now a retail unit. This is a regular 6.61 installation with regular PlayStation Network. I can do video stuff now, though I don't have any videos. So right now it's back to how it's supposed to be. So I'm gonna go over the custom firmware settings real quick. We have overclock, which is basically it sets the PSP to its maximum CPU clock of 333. The default speed is 222 megahertz. Power save basically underclocks the CPU to 166 megahertz. I don't really recommend it to play some intensive games, but you can play minis, you can play small homebrews, and you get that extra battery life. There's balanced energy mode. This one basically forces the 222, the default 222 megahertz CPU, even on games that try to use the overclock. So the vast majority of games, especially the older PSP games, will use the default clock speed, but some newer games will force the overclock, and maybe you don't want that because you prefer to have a few extra, like maybe 1 extra hour of fun, even if that means you have a few frames per second less. So people have choices, and that's good. And the reason it's separated into 3 instead of having one single option, like let's say CPU speed, and you choose overclock, power save, whatever. It's basically because you can enable settings on a per game basis. Basically, you can tell Arc, I want some games to run in overclock mode, I want some games to run in power save mode, I want some games to run in balanced energy mode. So basically, you need to be able to differentiate those 3 different commands. So basically, internally, it's like you're sending a command to Arc, like saying enable this on this game, and so on. The Autoboot launcher, it basically replaces the XMB with the custom launcher. A lot of people actually prefer to use the custom launcher. A lot of people don't like the XMB, and I get it. I mean, it's about taste, Memory stick speed up. This is actually a rather useless feature nowadays. It can help a little bit, but not as much as it used to help back in the day. Back when Dark Alex created it in M33, those compressed ISO readers were extremely unoptimized and they were very slow. So this feature actually improved them. But nowadays with Arc, we have an extremely optimized, extremely fast compressed ISO reader, and we have extremely fast memory cards too. So this feature, most people don't really see a difference. with this feature, but yeah, you can use it. Inferno Cache is a bit more of the same. This one was created by the Pro team also as a way to improve performance of compressed ISO, because they were trying to patch something to improve how CSO works, but the real issue was somewhere else. Skip Sony logos. This basically removes the PlayStation Portable boot, the Sony and PSP boot up screen when you boot a game or when you turn on the system. Hide pick 0 and pick 1. This one hides the background images of games when you're scrolling games in the XMB, so that the scrolling is faster, so it doesn't have to load a lot of things. Hide MAC address. This one will hide the MAC address in the system settings. When you go to system information, instead of MAC address, you're going to see your model. Okay, let's continue. Hide DLC. This one hides non-bootable DLC entries in the XMB because they are annoying to some users because they look like games. Sometimes your game has the DLC and they're in separate folders and they have the same icon and you don't know which one is a game and which one is a DLC. So this option allows you to hide the DLC so you don't have to worry about it. Turn off LEDs. This one is simple one. Every LED gets turned off and it doesn't, and you don't see any LED anymore. It can help save some battery. Disable UND drive. This one will disable the UND both by software and also try to disable it electrically for misbehaving UND drives or whatever or whatnot. Disable analog stick. The same thing. If you have a misbehaving analog stick, then you can disable it. And QA flags, as I just explained, QA flags makes the debug settings appear, which are basically useless. They don't do much, or not that we know, but yeah, it's cool to see it there. If I turn it off, reset VSH, you can see it's no longer there. The debug settings disappeared. Anyways, plugin manager. This one is a no-brainer. It allows you to enable, disable, and even remove plugins. Right? So it's your easy to go, easy to use plugin management system. There's not a lot to see here. You can see the plugin name and the plugin path, as well as the what's called the run level, which is basically where the plugin runs. Plugins can run in PS1, PSP. They can run on Homebrew. They can run in VSH or XMB. And they can run in specific games. For example, I have the Liberty City Stories cheat device is enabled only on Liberty City Stories via that's the game ID. Same for the classic VCS cheat device. And well, you can also do like the opposite. You can disable plugins on specific games. For example, if I have the Liberty City Stories and Vice City Stories cheat device already enabled, and I also have CW cheat because I want to use CW cheat in every other game, then it might be a good idea to not load CW cheat in the GTA games because I'm already loading a cheat device. So this line here, this configuration here is basically telling Arc that CW cheat is off on those two games. So here I am enabling CW cheat on every PSP game, and here I'm basically disabling CW cheat on those two specific games. So now I'm going to explain to you how you can install plugins in Arc because it's extremely easy. I'm going to go to the custom launcher, which I haven't shown yet. All right, there we go. So the custom launcher has been improved greatly since the last time I showed it. Well, first of all, now it's not crashing out of nowhere. There was a presentation where it crashed in the middle of me browsing it, and I remember it was because I had a 1.50 homebrew installed and it didn't like it. But that's fixed. There's full support for 1.50 homebrew as long as you have LEDA plugin installed. You're gonna have good compatibility with 1.50 homebrew. All right, so plugin installation. So here you have your first thing you're gonna see is your game menu, your game screen, whatever. Here's your in the left side you have your PSP games. In the middle you have PSP Homebrew, and in the right you have PS1 games. Right, so they're categorized in this manner. So if I press triangle here, it's gonna open up this menu, and I have multiple other screens. I have a file browser, networking stuff, and I have I have custom firmware settings and plugin manager, just like I have in the XMB. I have menu settings. These are settings that affect the custom launcher itself. It doesn't affect Arc. And what I'm gonna do is I'm gonna install a plugin. So to install a plugin, I go to the file browser, and usually in classic custom firmware, what you want to do is you're gonna be copying your PRX, whatever. Let's say AdPro, for example, this is Pro Online. You're gonna be copying your PRX, and then you're gonna be opening either game.txt or dsh.txt or pops.txt, which I don't have. But anyways, you're gonna be modifying these files by hand, basically. With Arc, there's no longer 3 different files for plugin handling. You have only one, which is plugins.txt. And the format has changed a little bit. The classic format was basically the path, followed by a space, followed by a 0 or a 1 to indicate if it's off or on. With Arc, the system is a little bit improved in a sense that it's much more powerful. As I just showed you, I can enable plugins per game, or I can disable plugins per game. So basically all the plugins are configured in the same file, where you use a comma to separate the configuration. First, you have to specify where the plugin loads. For example, this one loading in PS1, so gonna load for all PS1 games. Separated by a comma, you have the path of the plugin, SC plugins, LEDA, the PRX, whatever. Followed by a comma, you have off or on, or you can use the classic 0 or 1, or enabled, disabled, true, false. It does let you have a little bit more vocabulary, so to speak, when it comes to configuring your plugins. However, I do not recommend anybody to actually manually edit the TXT file, because the custom launcher and Arc in general are built to allow you to install and configure your plugins without ever having to modify the TXT file. And basically what you're going to do is, let's say I have a plugin, and here's my plugin. I just downloaded it from the internet and I copied it to the SC plugins folder, and now I just need to configure it. So how do I configure it? Right? I need this configured for Arc to see it and know where it works, where it loads, etc. So what I'm gonna do here is very simple. I'm just gonna open the PRX file. I'm gonna press X, and there we go. It'll ask me to install the plugin, and it'll just let me choose a few things. I can have the plugin always load. I can have the plugin load in game. Game is basically the classic game.txt. Basically, it incorporates both UMD-ISO and Homebrew. Okay, then there's POPs, PS1. There's VSH, XMB. Then there's UMD-ISO, which basically the plugin only really runs on retail games, like real actual games. And then there's Homebrew, like this plugin only runs in Homebrew. Then you have the option of entering the game ID if you want the plugin to run on a specific game. This is very helpful, especially with AdPro, the Pro Online plugin, because Pro Online isn't really compatible with every game out there. So if you're a Pro or ME user and you like Pro Online, you're gonna be having to enable and disable the plugin constantly, because if you change from a game that's Pro Online compatible to one that isn't, the game's not going to work. You're going to have to go back to the XMB. You're going to have to disable the plugin and then load the game again so that it works. Anyways, with Arc, you don't need to do that because you can tell it, hey, this plugin only runs in this specific game. So I'm going to show you how to do just that. Let's say I want AdPro to load. Well, I don't know if I have any game here that's actually compatible with AdPro. I mean, Tekken 6 should be compatible with AdPro, I believe, but let's just try it. Oh wait, actually, PSP 1K is not compatible with AdPro, with Pro Online, so I'm gonna use another plugin, maybe the HUD plugin, maybe. Whatever. I'm just gonna do it even if it doesn't work. Right. So let's say I want to install Pro Online, but I only want Pro Online to run with Tekken 6 with this game. So what I'm gonna do is here in the game menu, I'm gonna highlight the game here, Tekken 6. I'm gonna press the L trigger, and this window will pop up, and I'm gonna go to View Info, and here it's gonna give me the game ID and the path of the game. And here's the neat little thing: if I press X on the game ID or the path, or basically any of them, but especially the game ID, it's gonna copy it into some clipboard, and then if I go to Files and I open my plugin, I go to Game ID, I open it up, and I can see that my game ID is already pasted here in the Sony keyboard. So I'm gonna press Start, and I'm gonna select the first option, and my plugin is installed. And if I go here to plugins, to the plugin manager, I should be able to see AdPro. There it is. Installed only for Tekken 6. I'm gonna try to run it, but it's probably gonna crash because this is a PSP 1K, and Pro Online requires 64 megabyte of RAM. It requires the extra RAM that you can only find on the 2K or later models. Maybe it does load something. Yeah, it's loading something. I believe if I press, oh, there we go. If I press home, I have the Pro Online menu. So we can see that the plugin is indeed loading up in Tekken 6. If I go to any other game, I'm gonna use the L plus R plus start plus down key combo to exit back into the custom launcher. I'm gonna go to any other game. I don't know if this one. We're gonna see that Pro Online is not running on any other game. And as you can see, this is the normal behavior of the home button when there's no Pro Online. All right, so other things that I might want to show. Well, to be honest, what I really wanted to show was basically the XMB, the custom launcher. You have other things like the recovery menu. The recovery menu is basically based on the classic recovery menu. It's a mix between the classic recovery menu from your traditional Wait, actually, is this one isn't. I still haven't updated this recovery menu. Back to the launcher. So, though, to be honest, the recovery menu is not really that important with Arc. It's not as important as with other custom firmwares because Arc has a bunch of other interesting recovery options that are actually much more important, like the ability to disable and enable plugins using the start and select button when you're launching a game. So that alone is a lot more powerful than a recovery menu because if you think about it, most crashes or semi soft breaks, etc., are caused by misconfigured plugins, incompatible plugins, or whatever. There's usually you're not gonna have a break because the custom firmware is buggy. I mean, we I mean, I'm not saying that I'm a perfect programmer, but what I am saying is that Arc isn't. I mean, I'm not even the only programmer that worked on this project. There's a lot of brilliant minds behind this project, a lot of years, a lot of basically 2 decades of PSP hackers and PSP developers and some of the most brilliant minds of the community. I've basically grabbed all of that and put it into one single neat package. So you can rest assured that there's quality code, there's stuff. Everything that's done here is stuff that is well known, well understood. Um, Basically, right now, Arc is in a really, really stable state. So like, there's no major bug, there's no risk of break, there's no, basically nothing right now that would be considered catastrophic. As a matter of fact, I say it's actually less buggy than Pro and ME if you consider the fact that Pro and ME have some incompatibility issues with some games that I had to add some specific patches and specific game fixes. For example, and most notoriously, there's a lot of old games, very, very old games. For example, Outrun 2006, Street Fighter Alpha 2, that back in the day, programmers never thought that a memory stick with over 2 gigabytes was ever going to happen. So they basically coded the math, to calculate the free space in such a way that if you have a memory card that's over 2 gigabytes, it would overflow and become a negative number, and basically the game will report that you don't have any free space. And it's a well-known bug. A lot of people know about it. There's a lot of games affected. And basically, with Arc, you're not gonna see that bug anywhere on any game ever, because we patched a fix into the custom firmware, and you don't have to apply any CW cheat code or any other nothing. You just save the game, load the game, it'll work perfectly. Other than that, so what I was gonna do is I was gonna delete this old recovery menu that's no longer gonna. Wait, what? Oh, right, because version is this. All right, so I'm running on DC, so basically the installation folder is somewhere else. It's not in the recovery.pvp. This one is very old, no longer being updated because it was merged with the custom launcher. So back in the early stages of Arc 4, when I created a recovery menu, I had to do it kind of quick. So what I did was I reused the entire custom launcher code to do a very minimalist thing. And basically, when I created the classic recovery menu that I had to do it for full installations, I said, all right, look, I'm gonna grab the normal recovery menu and merge it with the custom launcher because that allows us to access the custom firmware settings and plugin manager from here, which is actually positive for Vita users. And at the same time, we don't have to worry about um, the recovery menu being too big for Flash Zero for a full installation, etc., etc. So if you have a full installation, well, you don't need a full installation anymore, but the new recovery menu is basically more like a traditional recovery menu. It mixes both the recovery menu from the traditional Pro, ME, M33 custom firmwares, but at the same time, it also changes like a lot of things with, like it mixes it with what used to be the traditional um, recovery menu for the original Arc 2 and the original Arc on Arc 2 releases. And this is stating a black screen. Interesting. I can just show the. I'm gonna try to show it on the PSP 3K. Actually, there's one more thing I wanted to show. Because I noticed that my PSP 3K is extremely outdated. It's on Rev 10 instead of 13. And I believe there's some errors here, some issues here. So well, I'm going to show you another feature that Arc has, and I'm going to update the custom firmware using the PSP's own Wi-Fi. I'm going to connect the PSP to the internet. You can see there's Arc 4 updater here. Update via internet. This is my phone's hotspot because the PSP has limited Wi-Fi. A fellow developer mentioned that in an earlier presentation. So I have to enable an open hotspot with my phone. Right. And now it tells me there's an update. And it's gonna download it. Alright, so probably one of the reasons why the recovery menu didn't want to load here is because this is running DC. And perhaps there's a small issue here. Well, actually, now it says it's running CIPL now. Okay, right, it's running CIPL now. So it should work. Try again. Oh, there we go. Alright, so this is Arc 4 recovery menu, which, as I said, it's based on the classic recovery menu that you find in other custom firmwares like Pro and ME. It has an exit, toggle USB. You can redirect USB to flash 0, flash 1, flash 2, UMD, etc. You have your custom firmware settings, your plugins manager, exactly like you have in the XMB or in the custom launcher. And then you have ProShell. And you might be asking, what is ProShell and why is it called ProShell? Well, ProShell is, like the name implies, it's a shell for Pro. And why is it in Arc? Well, basically because Arc is Pro. Arc is literally a continuation of the Pro, more like a rewrite of the Pro custom firmware for the PS Vita. It was originally called Pro Vita. So basically everywhere in the source code, you were going to be seeing the word Pro. Like Pro Team here, Pro Team there. And basically the original recovery menu that they created for Pro Vita, Arc, was called ProShell. And basically I just kept the name. It's called ProShell because it's made by the Pro Team. And it's basically for Pro Vita, which is Arc. And this is basically just a very minimalistic file browser with it can delete folders and files, it can copy and cut folders and files, and it can run stuff like I can open up an ISO, say it's really interesting if you notice how there's all sorts of different compressed formats here. Well, here there's only two. There's JSO and CSO. JSO was a very old format. It was created around the same time that it was actually the third format created for the PSP. It was created after ZSO and DAX. First one was DAX, second one was CSO, third one was JSO. but JSO never caught on. Though the idea was really good. The idea was to use a much faster algorithm instead of using the deflate algorithm. JSO uses LCO, which is extremely fast in comparison. The problem is the problem that the JSO format found back in the day is that it doesn't matter how fast your decompression algorithm is. If your actual CSO or JSO or whatever reader is heavily unoptimized and does a lot of I/O input-output calls, then it's gonna go slow as hell, and you're not gonna notice the difference between the two decompression algorithms. With Arc, that's solved. Arc has a completely revamped, completely rewritten Inferno CSO reader. That's why it's called Inferno 2. So the ISO driver for Arc is basically Inferno 2, is the second iteration of the Inferno driver, because it completely rewrites the entire compressed ISO reader and makes it much more optimized. It makes it compatible with every other format, so that, like, the same exact code, the same exact algorithm can read JSO, CSO, DAX. It can read them with 2K blocks, 4K blocks, 8K blocks, whatever block size, dynamic block size you want to use. And it's basically it's heavily optimized, and because it's the same algorithm, it's the same optimized algorithm for every format. With Arc, you can now actually see the difference with the decompression function. If you have the same exact game compressed using different formats, you're gonna actually see a difference, be it in loading times or in like in the GTA games, you're gonna be seeing a difference in the FPS, etc. So I'm gonna go back here to the PSP 3K. Has finished downloading a while ago, but I kept talking. So I'm gonna press X here to launch the update. And as you can see, it's extracting all the files. A lot of the files in the ArcSafe data folder aren't even used on the PSP. For example, all those POPs and PS1 SPU PRX files are for Vita users, but it really doesn't matter. They don't take up much space, and they're really unused. They're not gonna cause any issues. Arc knows what to use and when to use it. So it's basically it's really noob proof. Like, the custom firmware is made with the idea that you install it and you forget about it, and you just copy your games and play. It's really that easy. Like, if you noticed when I went over the custom firmware settings, which obviously different models are gonna have different settings. For example, the 1K didn't have the force extra memory setting. But yeah, basically most of these settings are just like stuff that are like customization, like customizable. None of these settings actually are like to improve or to, like, well, except for like maybe the overclock and the extra memory stick speed of Inferno Cache. Apart from those three, the settings are basically to customize the custom firmware a bit, but you don't have to mess around with ISO drivers like with other custom firmwares. Maybe one ISO driver has compatibility and the other one has a different compatibility. Here you don't have to worry about which one you have to configure and whatnot. So yeah. Other than that, I don't know. I have missed anything. I mean, I can boot a game if I've been trying all sorts of different games, all sorts of different things. Recently released Hilton Family Hack works perfectly fine. Been trying a few other things, homebrew games. This sort of stuff that fellow developers are also working on works perfectly. I don't know. Maybe I don't know if I want to boot up a game because maybe we get some copyright stuff in YouTube.
Yeah, no,
But yeah,
that's fine. Thank you so much for your presentation.
all right. So basically, any questions? Anything?
Yeah, I've transitioned us to the Q&A screen. I'll see if there's anything here. I did remember that there was one asking about you had the overclocking, the like power saving mode and all that. Can you enable multiple at the same time, or is it just one at a time?
Right. You can. I mean, I don't know what he means by multiple at the same time, but basically the reason why they're separated is because you can configure them to enable in different games or different modes. For example, maybe you want the XMB doesn't really need a lot of power. You can run the XMB just fine with power save, for example. Maybe the list of games loads a little bit slower. Depending on your list of games or whatever, it might not be an issue. Maybe you won't have. I have one PSP, the PSP Street, that I have right here. I haven't shown it. I have it right here, but I haven't shown it because it does. I mean, Arc is gonna pretty much be the same across all models, so it doesn't really matter much which model I'm showing. But I have a PSP Street that has a 4 GB, a really old Sony 4 GB memory stick that only has minis, like mini games. Like they don't really need a lot of power, so you can enable power save for those games. And maybe you have other games that do need the extra power, and you can say, hey, enable overclock on this one game and enable power save on the others or whatever. So basically, you cannot enable all three at the same time in one place, but you can enable all three at different places. You can have them configured to be enabled in multiple places.
All right, thank you. Another question that we have here from Slistrel is, can a button remap be made to assign to any game? So I think they're asking in the context of shooters, can you change like what the analog stick and like the D-pad or something does?
I believe there's a plugin that already does that. I tend to prefer to have a minimalistic approach to Arc, but at the same time, I want Arc to be fully feature complete to the point where it actually has more feature than compared to other custom firmware. So it's kind of like it can appear to be sort of like a contradiction. Like you want to be minimalistic, but at the same time, you have more features than any other custom firmware. But that's because if you think about it, if you can, most features in Arc are implemented in such a way that the user doesn't even really have to configure anything. The custom firmware already knows when to enable this and when to enable that. For example, there's a plugin called 660 on 661 created by David, which is a plugin that fixes 660 plugins on 661. The reason why 660 plugins don't work on 661 is because many plugins have checks to verify the firmware they are running on, and many plugins will not they will hesitate to run on firmware that they do not understand, that they do not that didn't exist when the plugin was made. So they see 6.61 and they panic and they don't want to do anything. But it turns out that 6.61 is actually literally 6.60 with updated network libs. So the vast majority, if not all, of the plugins will work anyway. So what the plugin does is that it fools the system to make it think that it's on 6.60 instead of 6.61. The problem is that the plugin caused issues with some games. It made them crash. Some very few games crashes with that plugin. So I was forced to find an alternative and create a built-in alternative in Arc. So with Arc, you don't need the 6.60, the 660 on 661 plugin. every 6.60 plugin will work on 6.61 on Arc without any additional configuration or any additional stuff. But the reason why I did that, the reason why I chose to say, oh, we have a plugin that already covers this, solution, already covers this necessity. The reason why, despite already having a plugin, I decided to cook the feature into the custom firmware is because the plugin was either incomplete, or in these cases was misbehaving with some games. Because the patch that the plugin applied to everything, applied to the system wide. Meanwhile, in Arc, because it's the custom firmware has a lot more control over the system than a plugin can have. I was able to apply the patch only on plugins and not the rest of the system, and that creates a more stable approach. And that's when I do accept implementing features into the custom firmware that I know that already exist externally. For another example would be the no UMD drive feature. There is a no UMD plugin, yes, but the plugin only disables the UMD drive on electrically at the syscon level. It doesn't do it by software. It doesn't trick Homebrew or games or whatever, or the XMB or whatever, into saying, hey, there's no UMD drive. Don't even bother trying to open it because there is none. So the Arc no UMD drive built-in feature does a lot more patches to ensure that the UMD drive is perfectly disabled, and also that software knows that don't even bother, because there's not going to be a UMD present. You're not going to even try. You won't even be able to read because the file system driver isn't even there. So basically, as far as I know, there's a lot of button remapping plugins. There's what's this one called? Macrofire, I believe, which was one plugin that works perfectly fine in Arc, that I actually had to add some patches to make it work that I think are no longer needed. But anyways, it works perfectly with Arc. And I believe there's some other plugins. So unless there's a real necessity for me to bake some functionality into the custom firmware, I would rather prefer for the user to find alternative in plugins.
All right. Another person asked, is it worth updating to revision 13 from revision 12 yet?
Not really, because revision 13 only really adds a PC program. It doesn't really change anything in the custom firmware as far as I know. Maybe there's some small code cleanup, very small stuff that wouldn't be necessarily noticeable. But Rev 13 was basically released for the PC app to create magic memory sticks. Because we noticed when we were preparing for the presentation, we were like, hey, did you notice that if you wanted to revive a dead PSP using DC Arc, you need another PSP that's alive? And we were like, that's not a good idea, because if you only have one PSP and it's dead, you cannot revive it. So we were like, okay, let's create and also because any PC app to create Despertar del Cementerio magic memory sticks are basically extremely old, Windows XP stuff, so maybe not that compatible with this and that. So we decided to do our own thing in Python, because Python works everywhere. So we created something that works on Windows, Linux, and Mac. So Mac users can create magic memory sticks, Linux users can create magic memory sticks, and Windows users can create magic memory sticks.
All right. Wilder asked, is it possible to create drivers for Arc, like for a controller or something?
Yeah, I mean, I guess there's many different ways you can extend the functionality of Arc. Aside from plugins, the typical plugins, one interesting thing that Arc has is that it probably has the biggest custom firmware API out of all of them, which means that there are many functions, algorithms that even other custom firmwares have, but they don't expose it for plugins to use. many stuff that is actually very important, very useful stuff for doing patches, for stuff for injecting code, injecting PRX, stuff like that. Many custom firmware even hide it from. And I've seen plugins. I've seen a lot of plugins, and I'm telling you, a lot of plugins that have to bake that functionality into themselves. Like they have to bake a function to do some patching on the kernel. When that function is already available in the custom firmware, the problem is that classic custom firmware doesn't allow you to call it. But maybe Arc does allow you to call it. It has a much bigger API with a lot of functions that can help you, and it has very recently for the pops for tool stuff that I made, to allow PS1 games to run on test kits. I added this small patch that basically allows you to inject any file into the custom firmware. So if you want to extend the custom firmware with I'm not talking about plugins, I'm talking about more custom firmware stuff, like actual files that will run side by side with Arc custom firmware files, you can do it. You can actually change a lot of things within Arc. It's heavily customizable. It's very modular too. Really modular. We try to make it so that there's a lot of different components that are completely independent from each other, and you can do a lot of cool things with it.
Nice. Total Commando asks, does Arc have some type of API that supports the IR Blaster for the PSP 1000? I want to be able to record and replay IR codes within the Arc firmware to control external hardware mods.
I no, I don't. I've never had such hardware with me. But if there is some functionality that maybe can be cooked into it to help or whatever, I mean, I would be very open for anybody who has this hardware and it's doing investigations and whatnot. I'm very open to assist in maybe cooking up something for Arc that would allow for better communication. I mean, the good thing about Arc is that it's still maintained. The source code is compared with Pro and ME. The source code is very clean, very well modular, etc. I mean, I don't like to shit too much on the Pro and ME team because they were my friends. Literally, Mr. Colbert was my mentor in the scene. But you can tell that they didn't really have much time to clean up the code for Pro and ME, and it sucks because there's a lot of times where I personally would have loved to do some really small maintenance work on Pro and ME, maybe release Pro C3, fixing a few bugs here and there, etc. But the problem is that you try to enter the code and they're built like a house of cards. You touch one little thing and you can break the entire thing. You can tell that they didn't really have time to do the extra work of refactoring, restructuring code, rethinking how to do things more. And I don't blame them. They literally had to do everything almost from scratch because the Pro team, they didn't have any M33 source code. They didn't have any of that. They did everything by reverse engineering the M33 and TN-HEN. And basically, they left the scene because some asshole leaked the first Arc version before it was publicly released, and so that made the team very mad, and they left. And it's like we couldn't do. There was not enough time to do anything for Pro and ME to make them in a state that other people can come in and say, hey, let's modify this, let's add this, But with Arc, I literally I made it. I've worked on it with the idea that I'm not maybe one day I'm like, hey, I'm done. I'm happy with the result, with the features, with the with what it has, and maybe I don't want to do anymore. And maybe somebody else can take over and say, hey, I don't think it's done. I think we can do this, we can do that. So I've always worked on Arc with the idea that it should be easy for somebody else with especially someone with knowledge of the PSP. It should be easy um, to play around with it and create your own stuff. I mean, most of the things in Arc aren't even installed on Flash Zero. On Flash Zero, you only have the core custom firmware stuff, the stuff that lets the custom firmware be a custom firmware. But graphical stuff like the VSH menu, the custom launcher, themes, language files, etc., they're all in the save data folder that you can see. Not here. Hold on. You can see it. You can see it in the save data utility. This is the Arc folder, and this contains a lot of modules, a lot of stuff from Arc. So you can basically just replacing the save data for your own thing. You can totally create your own distribution, so to speak. And I would totally be fine, and I would totally be happy to see that sort of stuff happening. Like somebody, even if you don't have a lot of coding knowledge, maybe you can just create but you can still create maybe a better custom launcher, or you can create a better looking VSH menu, or you can create a whatever, you know what I mean? I have tried to make it as easy as possible, and I've tried to make the code as clean as possible so that you can find where things are. You can see, oh, core stuff is in core, loaders are here, menus are here, extra modules are there, etc., etc. So it's really the idea is that Arc is not my custom firmware; it's the custom firmware of the scene for the scene. Like this is the result of, like I've said before, the result of a lot of people that I'm the head of the project currently right now, but if you go to the source code, you can tell that there is a lot of really bright minds that allowed for this to be what it is right now, and yeah.
Thank you so much, and thank you to all the contributors to ARC and the PSP community as well.
All right, so one last thing I wanted to say was I wanted in this conference to commemorate my long lost friend Gregory Pitka. You guys knew him as Quick Racer 87. He was quite easily one of the most brilliant, genius minds we've ever had in the PSP community. There is a lot of hacks, a lot of utilities, a lot of software that we still use to this day that are his contributions. And when we lost him, we lost a lot. And I wanted to remember him.
Thank you.
I'm done.
All right. Thank you for the presentation. That was really cool. All right. Thank everybody for watching, both all the viewers, all the homebrew developers, and all of the people in the community who make this conference possible. That concludes the end of the PSP Homebrew Developer Conference for 2024. Thank you guys.